All right. With this one, this is where I just pushed Surly and Aiden. Listening. When a force is applied to a certain object, its acceleration varies inversely with its mass. Okay? In other words, the more massive an object, the slower its acceleration. Okay? When they're actually launching rockets, they have to be very, very, very careful with the mass of the rocket because their acceleration is affected inversely with the mass. So the force needed will change greatly in a lot of cases. So you add like a kilo, and that could change the amount of force that they need to accelerate it to the correct exit velocity by a lot. Okay? So basically to push Aiden and Surly, I pushed Surly further because he is not as massive as Aiden. Simple as that. That makes sense, doesn't it? Yeah? If you're pushing two rocks, a smaller one will be easier to push, or a smaller one will go further with the same push. Yeah? All right. So here we go. First things first. A force is applied to a certain object. Its acceleration varies inversely with its mass. That's the first thing you want to know. So you know that it's varying inversely. Next thing. The acceleration of the object happens to be 12 meters per second squared. And the corresponding mass is 3 kilos. So we've been given some information. Cool? Now, first thing we have to do is we have to do a constant of proportionality, or the constant of variation. What do we do first, though? Well, you're going to have that fish and all that sort of thing. But what do we need first before we can do the fish thing? We need variables. What do you want the variables to be? Nah, they're not actually variables. They're actually values. Mass. Okay, so we've got M. Okay, and A for acceleration. Excellent. Now let's write the statement of proportionality. What's it going to be? Yeah, so which one's first, A or M? I'll give you a hint. A, fish. Okay. Is that finished? Is that correct? Is that correct? Why not? Not squared. That's now correct. We now have our statement of proportionality. You'll notice with these ones we haven't done any with cubic or anything like that. Because the inverse ones look like hyperbolas, you won't be given one with a squared or a cube in the inversely one. You just won't. That would be mean. Okay? So we've got A fish, 1 over M. So we've got A is proportional to the inverse of M. So now we have to write it as an equation, and that's going to have our K in it. How are we going to write it? What's it going to be? Or K over M. So you could have K times 1 over M or K over M. They're the same thing. Happy with that? Cool. So we've now got our relationship. We've written it with an equation having K. Now what do we do? My hand signals are getting bigger and bigger as the year goes on. All right, so what do we do now? Substitute. Excellent. What's our A that we've been given? 12. And you'll notice I'm not worrying about putting units in because our K won't have a unit. Okay, then we've got our K over what? 3. Awesome. And then we have to manipulate it so the K is on its own. We've got K divided by 3. How do we undo that? We multiply by 3. I'm hoping the K equals 36 on most people's desks. Awesomeness. So we now have our constant of variation or our constant of proportionality or whatever you want to call it. We've got K. Okay. Awesome. So that's A done. Tick. Find the rule relating acceleration and mass. We've done this in every other question. It's always been part of question A. This time it's question B. In other words, rewrite the equation. So what do we get? Yep. You got your two variables in there. A equals 36 over m. So that's part B done. Part C says find the acceleration of a 1.5 kilogram object, also known as. Okay. So we've got our formula. Have we got a value to sub in? Cool. So what do we got? A equals 36 over 1.5. Do we all get 24? 24 what? It's hey, thank you. Meters per second squared. That's our acceleration. So if we had a 1.5 kilogram object, the acceleration would be 24 meters per second squared. Now we have to do it with a 6 kilogram object. So same deal. Six. Thank you. Meters per second squared. It's important to have the units in these so that you can show that you knew what you were finding. A is your acceleration. Is everyone happy with that? Now, if they gave you the acceleration of an object, you could then manipulate the equation to find out what m equaled, correct? Excellent. We're all happy with that?